This lesson discusses groundwater as it pertains to drinking water. Support for the development of this lesson has been provided by the National Science Foundation through Ohio University's Boat of Knowledge in the Science Classroom program. Did you ever think about how much water you use on a daily basis? First, write down your guess of how much water you use in one day. Then pause the video and follow this link to a water usage calculator. Estimate how much water your household uses. Are you surprised by the result? On average, each person uses between 80 and 100 gallons of water per day. The largest contributor to household water usage is the toilet. It seems we use a lot of water, so where does it all come from? Why might water scarcity be an issue when almost 71% of the Earth's surface is covered with water? Follow the link and watch the video to find the answers to these questions. You found out your water footprint, but what about the water footprint that goes along with producing food items? This chart shows how much water in liters is needed to produce these food items. Notice that vegetables take relatively little water compared to meat, like beef, which takes 15,500 liters to produce. What about your average diet? The average American eats 736 almonds per year, 245 eggs per year, and 144 hamburgers per year, which adds up to a total of 116,681 gallons. If we use this much water for 3 different food items, how much do you think we use for everything else we eat? From the video we saw at the beginning of the presentation, we learned that the vast majority of our drinking water comes from groundwater. How does water end up underground? Water enters the ground through infiltration, which is basically rain getting absorbed into the ground. But water can only enter the ground through permeable soil and rocks. What does permeable mean? What do you think would be an example of a permeable material and an impermeable material? Permeable means that the material allows liquid or gas to flow through it. Sand is a permeable material, but concrete is impermeable. It does not allow water to pass through. Some materials, like limestone, allow little or no water to pass through, so they are called aquitards. Some soils are more permeable than others. What happens once water enters the ground? The water that enters the ground subsides until it reaches an aquitard, or the water table. A water table is defined as the level below which the ground is completely saturated with water. The area below the water table is called the saturated zone, and the area above the water table is the unsaturated zone. In the saturated zone, all pores between the soil particles are filled with water. In the unsaturated zone, pores are filled with water and air. Once water enters the saturated zone, it flows much like surface water in a watershed. This image provides a depiction of the difference between the unsaturated zone and the saturated zone. Notice the location of the water table. Similar to surface flow, groundwater follows a downhill path of least resistance. Groundwater cannot flow through aquitards. How do you think groundwater flow compares to surface flow in terms of speed? Groundwater flow is much slower, flowing at rates of meters per day instead of meters per second, like surface flow. Where does the groundwater flow go? Groundwater can reappear on the surface as a spring, flow into streams or rivers, flow into the ocean, flow into confined aquifers, form an underground lake, or be pumped to the surface. This diagram shows some of the possible outlets for groundwater at streams and the ocean. This diagram also shows recharge zones where water replenishes the groundwater. Notice that one stream is a recharge location, and another stream is a discharge location. Groundwater is recharged by streams that have an elevation higher than the water table, and discharges into streams that have an elevation lower than the water table. Groundwater can also be pumped from wells. Some wells occur naturally, called artesian wells. These wells occur as a result of high pressure in a confined aquifer. A confined aquifer is sandwiched between two impermeable layers. The artesian well will flow with water if it surfaces at an elevation lower than the recharge zone. Man-made wells are located in unconfined aquifers, which are above an impermeable layer. Springs are formed when the water table is exposed to the ground surface. Pumping drinking water from wells comes with some side effects, one of which is land subsidence. Subsidence occurs when water is pumped out at a rate faster than the recharge rate. An extreme example of subsidence can be found in the California San Joaquin Valley, which dropped 28 feet over a span of 52 years. Another side effect of pumping is drawdown, which occurs when nearby water flows towards the well to fill in water that has been removed. This behavior, along with the slow velocity of groundwater, causes the water table to curve and dip towards the well. The difference between the pumping water level and static water level is called the drawdown. This image shows an example of a drawdown curve. Notice how the water table slopes from the initial water level to the current well water level. Drawdown creates a problem for adjacent wells that are placed too close together. When one well begins to draw down the water table, the other well may go dry. Now let's consider a different issue. What if pumping stops? The opposite of drawdown will occur, and the well will overflow. Consider this example of overflow. The city of Lancaster, Ohio, recently built a new water treatment plant. The old plant treated groundwater, and when this plant was shut down, parts of the city began to flood. What happened that caused the flooding? The water table rose after pumping was halted. What do you think the solution should be? The city keeps the old plant running and pumping water to prevent flooding. Write the definitions for these key terms and review before moving on to the associated activity. Pause the video and try to answer these questions before viewing the solutions. How does water end up underground? It infiltrates, then subsides until it reaches the water table or an aquitard. Where does groundwater flow go? There are 6 possibilities: springs, rivers or streams, oceans, underground lakes, confined aquifers, or pumping. How does groundwater flow compare to surface water flow? Give a similarity and a difference. Similar to surface flow, groundwater follows a downhill path of least resistance. But unlike surface flow, groundwater is much slower, flowing at rates of meters per day instead of meters per second. What are 2 side effects of pumping groundwater? Land subsidence and drawdown.